For problem 24 on the practice test, determine whether the graph has an Euler path, an Euler circuit, or neither. If the graph has an Euler path or circuit, use trial and error or Fleury's algorithm to find one. Well, as I look at the picture, I see it's connected. I also need to look at the degree of each vertex. The degree of B is 3. That right there, being odd, rules out Euler circuit. The degree of A is 2, D is 1, 2, 3, 4, and E is 1, 2, 3. So it's connected. There are two odd vertices. It has an Euler path, but not an Euler circuit, because they're exactly two odd vertices. Exactly two odd vertices. Euler path, but not an Euler circuit. I'm pretty good at making the wrong selection there, because I fall into the trap that I warned you about. You've done these problems so many times that you don't read it completely and you pick the wrong thing. Or it doesn't say quite what you thought it said. That's the trap I fall into on this problem. Just because these two look a little, they both have Euler path and Euler circuit in the answer. So read it carefully, select the right one. Because it's an Euler path, it will have to start at an odd, the Euler path, and end at the other odd. So the two odd vertices, we have B, we have C. Euler path, but not an Euler circuit, that is going to be the case. Knowing that, I can look at some of those choices and scratch some of them off. It is not choice A. It is not choice D. So I'm left with two of them. I think I'm going to go and take a look at choice B. B goes from B to A. I would suggest you draw this graph on your scratch paper and trace through it with your pencil, rather than just looking at it on the screen, because that's a lot to remember in your head. Did I cover that edge or not? Okay, B to A is done. A to D, D to C. Either one that goes D to C is fine. Then we're going to B. Then we're going to D. And then we're taking the other edge that goes D to C. So it's the second one, choice B. Let's take a look at number 25. Examine the graph to the right. Determine whether the graph has an Euler path, an Euler circuit, or neither. If the graph has an Euler path or circuit, use trial and error or Fleury's algorithm to find one. Fleury's algorithm is just trial and error. That's what it is. The book describes it as erasing the edges as you go, but you're still doing trial and error. Well, this is a connected graph. Vertex C has degree 3. A has degree 3. That right there, two odds, rules out Euler circuit. One more odd will rule out an Euler path. B is 3. There's 3 odds. You don't even have to look at the rest of them. This graph has neither an Euler path nor an Euler circuit. So I will select choice D. This graph has neither an Euler path nor an Euler circuit.